So today we are going to discuss solution of the state equation. So it is like solution of the state equation where we will investigate solution of a general form of equation given by only thing that we can figure out from this description is that well, let me tell you. In addition, another assumption you can make is that all the entries of this n cross n matrix is continuous function of time t. They are not any kind of discrete jump you can experience here in that function. That's it. And obviously we are looking for with respect to a particular initial condition xt naught is equal to x0. Now in my last few videos there were several questions were asked, like whether to mention both t naught, xt naught, or mentioning only xt naught is sufficient or x naught is sufficient, like when our solution will be dependent on explicitly on t naught and when we will be in a position to means we can ignore t naught, rather only the amount of time spent between the initial and final time will make the, or means initial time and the observation time, that will make a difference, means any impact on us. So that's what is what was all about that confusion. Now before I start today's discussion, I would like to answer that. As I have mentioned that for LTI system, that is linear time invariant system, you don't need to consider t naught. Only having knowledge on x naught is sufficient. Now let us try to understand how and why. And unlike other videos, today I'd like to consume some extra time for elaboration, and if that elaboration takes something extra than 1 hour, that should not be considered as the time of that video. Like as I have already promised, 40 videos, each of them will be of 1 hour or nearly 1 hour duration. This video may continue till 1 hour 15 minutes, but it should be treated as a video of 1 hour duration. Now let's get started. So here one thing, just a minute. So well, for LTI it is x naught is sufficient, and for your solution for time varying system t naught and x naught both are required. But as you might get confused that because xt naught is always x naught, so why we need to mention t naught and x naught both of them for time varying system while mentioning x naught is sufficient. Apparently it gives you an impression that having x naught, idea on x naught is sufficient, but that is not the case in case of time varying system. Let me give you two examples. Let us say you have two different kind of time machine. The first time machine that allows you to both of them allow you for time traversal. Like from current age you can reach to medieval age. I am not good at history. Maybe the medieval age, what I could figure out, it was from 600 to 1500 AD or something like that. People consider it was medieval age, but not means let us get there. But let us say, or say we want to witness the Christ birth. So both of the machine can transport you back to that time when where you can witness the Christ, the newborn baby. Well, so let us have two time machine. Both of these are so powerful that they can allow time traversal, but one of the machine is having a facility that when you experience time traversal, or means you that machine, say machine 1, the time machine 1, then time machine 1, even after time transportation, it allows you to means stay the same you in your past or in future time. And the other machine that can also allow you the time traversal, but it cannot ensure the same you will be there when you will reach to that particular point of time. Let us take an example. Suppose you are having two machine, time machine 1 that can keep you as you are at present moment, and time machine 2 is not that powerful. It cannot keep means ensure that you will remain the same person. Now with time machine 1, you try to reach say 100 AD. So once you, now we are at 2021 and you are trying to reach 100 AD with both the machine. So that is kind of medieval age from history perspective, or maybe I may be wrong, but means you can consider it like that. It's quite an ancient age. Now with this time machine 1, when you reach there, suppose before means boarding to that time machine 1, you are having 10 rupees in your pocket. So once you reach there using their time machine 1, even you are at 100 means AD, you will see that the people are different, but whenever you are trying to interact with them, they are, this is very important, that your system means whenever you are trying to interact with the people, they are also interacting with you in similar manner. Like now if you go to your Rincon canteen and means ask for a means say jalebi or bora, you need to pay 5 rupees. So same thing, even at that 100 AD, you are going there. Although at that time they were having some different value of currency, people are wearing some different outfit, they are having different language. But when you are you go there, you can that is the facility of time machine 1. It will allow you to interact with people in modern language. You can spend 5 rupees, and then when after having that bada or jalebi from your say that shop, like means the time machine 1 will create that ambience and environment like you are in call canteen, but you are actually in 180. But after having your item, you can again board to the time machine and ask it to get you back in that means your current time. And here means when you will reach here at your present time, you will find yourself inside your home or wherever from where you took your means you started your journey there with a vada or jalebi or remaining 5 rupees in your pocket. Now this is an example of time invariant system. So why I just trying to tell you this story because when you are doing this time traversal, the idea of time invariant means means whatever you will have means your behavior or whatever you will do, it is immaterial of the time traversal. So whether your T naught is something means your initial time, say you started at 8 January 10 a.m. in the morning, or you started in some other time. Every time you are reaching there with your 10 rupee in your pocket, and then you are getting the item and everything remains same. You are not going to get affected by the external factors, as well as you can still interact with the external system without any difficulty. And then another system, that is time varying system, like your time machine 2. It can also allow you to go for a time traversal. You can reach 100 AD, but while reaching at 100 AD, you may find surprisingly that once you reach 100 AD, instead of 10 rupee in your pocket, you may have some kind of like bronze or silver coin in your pocket that is equivalent to that time, means some money in that type of currency, and that may be more valuable than 10 rupees, or means the amount of coin you will have at that time, your outfit, your means outlook, everything will change, and you will find yourself as a complete different person if you go with that means do that time traversal. But one thing that is important to understand, that even if you are doing that time traversal, whatever that 10 rupee in your pocket you were having initially, you will still have something that is, if we consider that 10 rupee represent something equivalent to energy, you will, after even your time traversal, if you consider that during time traversal you have not done anything or doesn't interact with anyone, means you do not interact with anyone or the system doesn't allow you to interact with anyone, you will still have something that is equivalent to your that 10 rupee in your pocket. Now here, because now for this system, if you start at 8th January 2021, you will, once you reach to that 100 AD, you will find some kind of coins in your pocket. If you start at, say, at, means, suppose, assume yourself that you are also present there, and say during Indian means freedom struggle and Indian independence. So suppose you are there and you started means you started at say 15th August 1947 with that time 10 rupee in your pocket, and when you will reach there, is from 15th using time machine 2, you reach there, you will find some thing in your pocket in there, means 100 AD currency, but just because that 100 AD, like now you are having your 10 rupees having some value, and when if we consider ourselves at 15th August 1947, at that time 10 rupee was much more valuable than its means current value, whatever monetary value a 10 rupee note is having right now in our current days. When we were there at 15th August 1947, it was means that monetary depreciation, if you consider, it was quite a valuable, means like current days 1000 rupees or something like that. So when you, with that 1000 rupee, when you allow your traversal to that mid-level edge, you will find that you are having something like, if you start today in 180, you will find you may have 10 bronze coins in your pocket, and when you reach from 15th August 1947 to that same date of 180, you may find that your pocket is full of 1000 bronze coins. So it's like that. So here, but when you are, if you do the same experiment, that means if you start your same experiment with time machine 1, because time machine 1 allows you to be yourself wherever you travel, in past or future. So with 15 rupees, means on 15th August 1947, you start with time machine 1 with 10 rupee in your pocket. You reach there, and then also whatever means 5 rupee item you could get, you could spend 5 rupee item and you can return here. Now the question is that how? So obviously in case of these two systems, only because for the second system, that is less costly or time varying system, the system get changed, everything getting converted once to some value and again getting converted to some other value. But in case of your like time machine 1, linear time invariant is only dependent on the means how much you have spent, and then like this spending, although it's not quite analogical, but you can think that how much time you have elapsed from your initial to final. That's it. It has nothing to do with means at what time you have started. But for on the contrary, for time varying system, it is very important for you to know at what time you have started. To get a better mathematical idea, you can consider two systems. One system, this is an example of LTI system having some state model like. So basically it is independent of t. You can start anywhere, and you can consider another system having state model like. So these are, both of these are second order system, but how in here, if your t naught, here t naught, it can be anything 0, 10, 1000, it doesn't create any impact, so you can always consider it's 0. But here you can see that having t naught is equal to 0, t naught is equal to 10, t naught is equal to 100, always give you a different AT. And that is why the entire system dynamics change. So that is why the time invariant system has earned, you must have studied all this in your digital signal processing, but still it's kind of reinforcement learning. When I was young, there was a popular serial. Right now, I do not have television set, but at that time it was very popular. Name of that serial was some CIT. What they used to do, a few officers used to means it was kind of reinforcement learning. Suppose officer 1 tell something, then officer 2 tell that similar thing in a different manner just by some paraphrasing. Then their boss also reasserting that. So it's like a kind of reinforcement learning. So here also I have spent some time, say 19 minutes I have consumed from your time to just reinforcement what you have studied in your basic control and your digital system, digital signal processing. So what I was trying to discuss that perhaps you have got certain idea that why in case of LTI only x naught is sufficient and why for time varying system you need t naught and x naught. Now come back to this x dot t at xt. More precisely, we can express this equation where at is all these elements of at are continuous function of time and xt now. So by definition you can expect that what we mean by the term solution. Solution of state equation or any differential equation is defined as continuously differentiable you can say in class 1 function or n dimensional vector xt, but it is better to say n cross 1 because you are talking about continuously differentiable. So the function xt that satisfies this equation with given initial condition, this xt for all values of t greater than is equal to t naught, it satisfies this equation. Now like first of all, whether a solution of such kind, obviously when we are describing system in this manner, we have accepted that our system is linear in nature, at least linear in terms of state vectors. So that is why here we are representing it in this way. Otherwise, we cannot write it in this kind of form. At, whenever you can represent it in this kind of linear vector matrix form, it implies you are dealing with linear system. Now linear system can be linear time invariant and linear time varying system. Now this LTI or LTV, whatever you are having, now think about that here this LTI or LTV, it is like like how can you know that a solution will exist? Although we have mentioned some thing regarding structure of AT, that all entries of AT is well defined and they are continuous, but it is it is a give us an scope to intuitively expect a solution, but we have to prove that solution really exists. Now here, when proving that, it needs some kind of mathematical training, and if you need to consider that non-linear system, then you have to go for contraction mapping, but we are not going to deal with, because here we are only at present we are dealing with linear system. We do not want to make it much complicated. So better let us guess for a substitution, like guess for a solution of this equation, and then substitute it to the means, suppose I claim that say a vector that is say x dash t is a solution. So how can you prove that x dash t is a solution? Very easy. You just put x dash t here. You see that differentiating x dash t with respect to time, and after that whether x dash t holding the same relationship or not. So it is kind of unscientific and kind of means it is the approach what I am recommending. It's not appreciable, but we want to avoid complicated mathematics. However, even if we consider having some kind of expression, it is only possible when we are having something like this. We boil down to a one-dimensional case like where a is and a is also constant, right? So a won't vary with time, or a will become a constant function of time, and you are having xt, then you can easily predict the solution. But how to generalize this one? That is the best means biggest question here. So what we can do here is that instead of having a solution, what we can do, let us consider for t naught and x naught, for t naught and x naught, let us assume an arbitrary time t greater than 0. So now with this t greater than 0, let us construct a means sequence of vector function. What is that sequence of vector function? This sequence comprises obviously here it is xkt defined on an interval t naught to t naught plus t. We are talking about, this is called closed interval. Why closed interval? Because you are including the two boundary value in your description. In case it becomes half open, then what you need to do, it is this. Now obviously like when you will take a very crude picture, then this kind of open set closed set doesn't make much difference. But if you I last day I discussed about that, it is all about your objective. What objective you want to means accomplish, and for that what you need to do. Engineering is all about that objective, means your objectivity changes the whole picture. When you are going to design a control law for a chemical plant, and when you are going to design control law for a surgical robot, you should not no one, even the stalwarts of control engineer, cannot figure out a single control law that will find application in everywhere. Although we claim that control engineering is ubiquitous, you can find its application in all the sphere of your life, but one control law that can handle everything, it's impossible to find. Although I have a very little knowledge, but I can guarantee you that it's impossible to find. Philosophy may find its philosophy maneuver, but the precision, the everything will change case to case. So similarly here, we must not make things means like there is one is rigor and another one is very crude and a bird's eye view. So we should try ourselves to be close to that mathematical rigor as long as we can do that with our limited knowledge. Obviously in some cases we cannot means go through or analyze all these mathematical rigor, rather we have to accept something like an axiom, but proof is possible, but those proofs can be discarded. But as long as we are means it is possible for our understanding, we should not break that practice of means or means we should be very precise. So this is a closed interval, right? Now when you are talking about this, then what is the idea? The idea is that these functions, we do not know the solution, but more higher order function you are going to take. This function is going to the means you keep on increasing this k, and eventually it will like merge with your actual one, right? So now many things may come in your mind. Let me write a few further steps, otherwise you won't get what would be there to confuse you. Like first solution is, so why should we consider x naught? Because again I would like to remind you the dimension of x naught is means x naught is something like this, right? So here we started at time t, means at time means our interval is t naught to t naught plus t. So we are here that x naught t, at least at time t0, it was good enough to consider x naught as a solution. Then we take another one, x1t, that is x naught plus so what I have written here. Well, here I must mention one thing, just a minute. So, well, here I must mention one thing, that here whenever I am writing t, this belongs to this set. Now we are having our x2t So basically what change I am doing, I am starting from same time, going to same time, but that transition, what I am considering, that transition in case of, let me write the third one, then it will become much more clearer to you. So basically what I am doing here, try to understand that this x naught remains constant. Now other than that, x naught t is equal to xt. Obviously, this is all good for when you are at t is equal to, and there is no means ambiguity, because that is why, if you can remember, I have taken this term. This is closed interval. Where is my cursor? Yeah, this is closed interval. Had we started with something like this, I can't include this one as my first approximation. What I am doing for this is for the entire range, right? So x1 is an approximation. It also gives you the approximation value from t to t. Now, when you are trying to write x2t, what x2t is doing, it is like in x1t, it started from x0, but then it gives you a direction that how x1t can be. Now we are defining x2t, means we are trying to take an iteration. We are defining x2t that started with x1. Obviously, if you take t is equal to t0, then you can see this whole thing will means in all these three equations, all these terms will become 0. Only x0 will remain, and that is quite natural. But then what I am trying to say, it is like say you are having one curve like this, or any regular curve. Now this is your point. Obviously, if you consider this curve in two-dimensional place, then you are having a two-dimensional vector. In that case, n is equal to 2. Since you are dealing with R2. Now, then you are having one x1, that is something like this. Then you are having x2, that is like this. Like our approach is to make things means utilize this information of the one, so that we can reach to close to the solution. But we even do not know that the way, here I am showing you graphically, but we do not know even that whatever we are doing, actually we are moving towards the actual solution, or means if we go means that index means or means take a function, say instead of x1, x10 is a better approximation of our solution or not, we do not know. For that we need to ensure that convergence of our sequence to a particular solution. But whether it will converge or not, that even we do not know. Let us do it, and eventually we will be able to prove it. So here, then what you are having at the end, and here k is equal to 1 to means like this. Now if we like take this xkt here, what we can write means xkt, we can write it like So when you expand this iteration, like xk minus 1, uh, that will take that xk minus 2 here. So what you will have here, it is difficult for me to write in that reverse way, means starting from k to going backward. Let me do the easy things that is easier for me, is to write and eventually at it ends at similar to, at the end it is t sigma 1. So this gives you a form of means xkt. Now this now you can see that this whole thing we can write it as a form of telescopic sum. What is telescopic sum? You can do Google and figure it out. It's actually the sum when, like 1 minus half plus half minus 1 by 3 plus 1 by 3 minus 1 by 4. It's like that. So what you will have here is like, oh God, we have reached the end of the page. We will have something like true. This is true for k is equal to 1 to blah blah blah, like increasing integer value. So then the sequence of these partial sums of infinite series will become what? Got it? So then now this convergence of the series are equivalent to that convergence properties of the sequence, because this is a series but this series is formed in such a way it has become a telescopic series, means sum, and then if we can prove that this is going to converge to our actual solution, what we are expected from our system, then we can prove it. So we need to prove the convergence of this series, right? So now what we can to means proceed with the proof further. Let us assume two constants. One is alpha, that is the and the other one is like beta. So this is all are alpha and beta. So think about the dimension of alpha and beta. I'd like to hear from you, okay, in our discussion. So anyway, one thing that is very clear to us is that alpha and beta are finite or bounded. Why? Because your this in the region we said AT is continuous and well defined, means all the values of AT are continuous and well defined. So obviously you cannot expect, even if it is a very big number you are having in entries of AT, or for any time you are having a very big value, but it is somewhat a finite number. So obviously alpha is a finite number. Then what about beta? Beta is something you are means doing means integration means area under the curve. You are integrating uh, a curve within means you are considering a curve duration within a finite interval. Typically this capital T indicates the duration, and the height of that curve above that your datum line. Now width we got, width is capital T. Now height is also bounded because this is kind of means all the entries whatever you are taking, that is bounded. So if you consider, forget about this integration and all this, if you consider a rectangle whose height and area, width are bounded, so obviously the area of the integration, area of that rectangle will become bounded, and here it is also bounded. Now here what you can have is that AT is, so what we can write here like so this will become, we can write it, it is less than is equal to because this t is can be t naught plus t here. If you go up till capital T, you will get beta. So here this t is less than is equal to t naught plus t. So obviously this outcome will become less than is equal to beta. So what we can say in a nutshell, that this whole thing is basically less than is equal to beta, right? So similarly, now let us do for it for this one x1 t x2 t. Now it is something like basically this one could be written like that means x naught also, there is no such sum. So what you will get here is like this one is less than is equal to, same technique we can apply, that is now this inequality would like to exploit here. So this gives us what? This gives us it is this is alpha, and like this whole thing we can write it like it is less than is equal to beta alpha t minus t naught, where t is t belongs to your that one, like t belongs to your t to t0 plus t. Okay, now let us go to just a minute. So in general what we can show here is that in general form t to t naught. Sorry. After watching this video, you people will understand the true beauty of this mathematics. So now here it is like we are already know. So eventually this leads us what? This leads us to don't get surprised with the result because here see how it's coming. If you see the first last stage, then it is like these are x2. So when you are talking about x2, it is only one x1 2 and x1 is like, now when you will take the difference between x3 and x2, what would happen? Here you will get a x2 and here you will have x1. Then you need to go one further step. So that will give you what? That kind of things that I wrote in the last page. This kind of situation will take place, right? That x3t will become this plus this, yeah, till this you will get in your x3t. So that is a very important thing. Like here you can see I have written x3t. So x3t, if you have to means figure out x3t, you have to write x2 in terms of this, then x naught. So basically what you can write here, that I have already written in generalized format somewhere here, yeah, it is all means for x3 you will get x2 here and x1 here. So gradually if you do it and try to just be a bit, you just need to imagine that how things are going, then you could figure it out. That is not a big deal how this is coming. Now we need to apply Weierstrass M test. What is that Weierstrass M test? Let me quickly remind you. I forget whether I shared that Weierstrass M test with you or not, but let me tell you that that is the infinite series of positive real number given by this converges if converges like, and if xj t less than is equal to alpha j, Now obviously here what is xj t, that is when you do a differentiation like this is a infinite series of continuously differentiable function over a particular time interval. We need to prove that it converges uniformly to some particular value x cap t. If the series converges, then like we are actually we are talking about convergence of this xj t. Now what is here, that if the infinite series of positive real number alpha j, alpha j has nothing to do with xj, only thing with alpha j is that for all values of j, the values of that vector function is upper bounded by alpha j for all t belongs to that interval. In our case it is t0 plus t. Then your original series, that is your that original series is this one. If this series converges, then the original series, that is that will also converge. That is our Weierstrass M. Means let me tell you once again, if we add a series of positive real number, infinite series of positive real numbers, and find that series is converging and finite, then we are having another infinite series, but the condition imposed is that every element of the second infinite series, that is xj series, is smaller than the corresponding element of that first alpha series, right? So that is our Weierstrass M. Now how we can apply here the concept of Weierstrass M, that is interesting to see. That is here this whole thing we can write like this. It is x naught, and the case for because tj capital T we have taken because it is the maximum amount. Clearly this is going to converge. Why? Because even if you are going to take the values of this, then means all the time if you keep on taking this series is going to converge. Actually here, what is your alpha? Let me tell you first your alpha. Alpha with this one, this alpha j, what is alpha j for our present case? This is our present case. Now the alpha j for our present case is this much. So now where it will converge, it will converge to somewhere like, so the infinite series is converging to our uh, that series of is that series, yeah. So this series where I have written yeah, this series, I'm talking about this particular series. This series is going to converge at our uh, this series is going to converge at what I just write, this one, right? So now it is quite clear what do you mean by the term existence. Existence means when something is finite. So now the question is that whatever we are getting by doing so, whether it will means represent the actual solution or not, means right, whether we can fit it to our original equation x dot t is equal to 8t xt or not. So to prove it, what we can do is that simple take the differentiation, like we are claiming our solution to be like this. And eventually it goes to where? It goes to some term like this. This is the whole thing. Now let us take the differentiation. If you differentiate, what you will have? This is a constant point, so this will go away. You will have, this will become a naught, a sigma 1 means here it will become, then here you will get what? Then similarly here you will have what? Now here it is clear that we are getting everywhere this factor common. Sorry, here it must be x naught should be there. Here you will have this factor everywhere in common, and also this x naught. X naught is present here, here, and here. So can we write this whole thing like I plus T naught T A sigma 2 D sigma 2 plus AT is equal to, we are trying to write it. No, sorry. That whole thing, if you consider what was there, just just a minute. Just a minute. Well, now we are all set. So this is like d sigma k, this integration, the d sigma k to d sigma 2 d sigma 1, like this. So if you see this whole thing, this is again, isn't it the what we were means we have started our journey with this. We were in a mood to approximate xt by this function, this xkt. So see what we are having here at the end. We are having this. So now we can write it is like, then further you can take, so this is, well, this is giving us the equation back, x dot t is equal to atxt, no doubt about it. Now another thing what we can write is that like this whole xt, if we consider the whole xt, it was like, again it was like, if you take this x naught and what it was, so this is something like our function that ensure this transition from x naught to at. So this one is denoted by phi, let me use a different color. Well, so this is known by state transition matrix or transition matrix. So this is all about existence. Now we have to prove the uniqueness, like only one solution can exist. right? And it is clear that uh, this one, like um, this state transition matrix, it what I would like to say that it is very clear that this phi, it depends on the two variable t and t naught. So this is all about existence. In next video we will discuss uniqueness. So it was, well, 1 hour because I took 19 minutes to explain that. So here it is 1 hour 16 minutes.